2.6, extreme values of functions. An extreme value is the largest or smallest value of the function on a given interval. They're also called maximums and minimums. Okay, so extreme values of quadratic functions. So we have the quadratic function in standard form, ax squared plus bx plus c. So we're going to graph f of x equals 3x squared minus 6x plus 2. So we list out a is 3, b is negative 6, c is 2. We find the vertex, so x is negative b over 2a, negative 6 over 2 times 3. So x is 1. So we plug that in to find y. One squared is 1 times 3 goes to 3, minus 6 plus 2. So y is negative 1. So our vertex is 1, negative 1. Our a value was 3, so it opens up. So we start by plotting the point, our vertex. Draw our axis of symmetry to make it easier to graph. So I'm going to use the 1a, 3a, 5a trick that I showed you in class. And our a value is 3, so it goes up 3, right 1, and reflect. Then we're going to go up 9 and over 1 from the blue dot. So it's a little bit off the page. Which is okay. We still see the form that it takes. It's a quadratic. So when looking for an extreme value, we're looking for either the highest point or the lowest point. Well, the highest point, the graph of the parabola is going to keep going. So there is no highest point, but there is a lowest point. And on parabolas, it occurs at the vertex. Lowest point is also called the minimum. So the extreme value in this case is a minimum, and it occurs at the vertex 1, negative 0, 1, negative 1. So a maximum or minimum value of a quadratic function occurs at the vertex. Remember that the x value formula is negative b over 2a. And if a is greater than 0, so it's positive, it's minimum value. So if it opens up, it's a minimum. And the minimum value is the y from the vertex. If a is less than 0, which means it opens down, then it's a maximum value at the y value of the vertex. So we're going to find the minimum or maximum value of each quadratic function. A is f of x equals 6x squared plus 18x plus 13. So our a value is 6, b is 18, c is 13. So we got to find our vertex. X is negative b over 2a. So it goes negative 18, over 2 times 6. Go to negative 18 over 12, which reduces down to negative 3 halves. Okay, now we need to find our y. So y equals 6 times negative 3 halves squared plus 18 times negative 3 halves plus 13. Negative 3 halves squared goes to 9 fourths times 6. And we can cross reduce 2 and 3. Goes to 27 over 2, which is really 13.5. 18 times negative 3 halves, we're going to reduce to make it easier, goes to negative 27 and plus 13. So 13.5 minus 27 plus 13 goes to negative 1 half. So our vertex is at the point negative 1.5, negative 0.5. And we really care about where the minimum or maximum occurs. And because this opens up, it is a minimum. At the y value, negative 0.5. Now we're on to part B. F of x equals negative 4x squared plus 32. Our A is negative 4. B is, oops, that's 32x. B is 32. C is 0. There isn't one, so it's 0. We see A is negative, so it's going to open down, which means it's going to be a maximum. So now we need to find where it occurs by finding the vertex. X goes negative 32 over 2 times negative 4, and that simplifies down to 4. So plug in 4 for x. F of 4 goes negative 4 times 4 squared plus 32 times 4. So we work this out, it goes to negative 64 plus 128. And we get f of 4 be 64. Now we wouldn't want to graph the vertex at 464, but we know that its max at y equals 64. A real-world example, we have the suspension cables between the two towers at the Mackinac Bridge in Michigan, and it forms a parabola that can be modeled by the graph of f of x equals 0.000097x squared minus 0.37x plus 549, where x and y, or f of x really, are measured in feet. What is the height of the cable above the water at its lowest point? So here's the lake. We have two towers coming out of the water that support the road. The bridge, if you would. And from the top of the towers, there's a suspension cable. And it forms a little parabola. And so we see that it hangs, it opens up, and it hangs down. So we know it is a minimum. We have to find this value. So we need to find the vertex. So x equals negative 0.37 over 2 times 0.00097. If you use your calculator, you're going to find it's 1907.21, etc. So let's just go with 1907.2. So now we need to work out f of 1907.2 equals 0.00097 times 1907.2 squared. Minus 3.37 times 1907.2 plus 549. So of course you would want to use a calculator for this problem. Plug it in. And we get 196. So this means the bridge, the cable, is 196 feet above the water. At its lowest point, of course. If you have a graphing calculator, let's go ahead and look at f of x equals x cubed minus 8x plus 1. So I'm opening up my graphing calculator, type in the equation. And we get a fairly large curve. Okay, so this is a rough sketch of it, and we're going to notice a trend with x cubes that it's going to have two peaks. And so that means we have both a maximum and a minimum. And we call these local max and local min. And we will find out a way to figure this out later in the semester.